I welcome you all for the operating system lecture series. In the continuation of deadlock, we'll see today the first deadlock handling method, which is called deadlock prevention. As we have seen what is deadlock prevention and how it works. So the deadlock prevention works based on the four necessary condition of that deadlock. So these are the four that is called Coffman condition of deadlock. The first one is called mutual exclusion. Second is called hold and wait. Third is called no preemption and circular wait. When the set of processes follows all these conditions at the same time, then the deadlock can occur. So these are the necessary condition for the deadlock. Now, if we'll talk about the deadlock prevention, so deadlock prevention says that if we target any of these condition and we prove that any of these condition is violated or it is not happening into the system, then the deadlock will not going to occur. So the idea behind deadlock prevention is to violate any of the necessary condition of the deadlock. And by doing that, we are preventing the deadlock. That is called deadlock prevention technique. It is the first deadlock handling technique. So the design will design such a system which violate at least one of four, that is one of four necessary condition of deadlock and ensure independency from deadlock. So that is the idea behind the deadlock prevention technique. It says that if we design a system in such a way so that it will violate at least one of four necessary conditions. So we have seen that the four necessary condition will target any of the condition and will try to and ensure that that condition will never occur. So the deadlock also will not occur into the system. That is deadlock prevention. In the deadlock prevention, there are different methods, different techniques. We'll see one by one. So the first set of methods in deadlock prevention is how to violate hold and wait. So what is hold and wait? In the hold and wait condition, a process is holding the resources and waiting for other resources, which is again held by other resources. And that wait and hold will be done in a circular way. So how to violate this? So the first approach is a conservative approach. In this approach, processors allow to start execution if and only if it has acquired all the resources. Less efficient, not implementable, easy, deadlock independence. So the first is the conservation approach. What this approach says that if a process P, if this required resource R1 and R2 and R3 for execution, so either all resources it should hold or none of the resources it is holding. Means, let's say if it is acquiring R1, so it should acquire R2 as well as R3. Otherwise, it has to release all the resources what it is acquiring. So the process will start its execution if it is having all the resources what is required. Okay, that is called conservative approach. The second is do not hold approach. What is that? The process will acquire only desired resource, but before making any fresh request, it must release all the resource that it currently holds. It is efficient and implementable. It says that it is efficient as well as implementable. Now, the process will acquire only desired resource, but before making any fresh request, it must release all the resources. So let's say P is requiring R1, R2 and R3. Let's say it is getting R1 first. Now with the R1, it will execute the process for some instance. And then after that, it required R2, right? as well as R3. So let's say it required, next resource it required is R2. It will give R2 when it will release R1. So that R1 need to release before P will give R2. So in this way, hold could be violated. It is an efficient as well as implementable model. Why it is not implementable model? The first one, because in the system, when a process will enter into the system, at very first, process cannot define that I need these much of resources, or I need these are my minimum resources, minimum number of resources that is there. It means that the process cannot reveal, or the system cannot know how many resources are required for a process to execute its all execution code, or the system will never going to know how many resources are required to execute a process, right? So that's why it is not an implementable. Here it is why implementable, because the process is requesting the resources one by one. That's why it is implementable model. So whenever it required, it will ask the system or ask the operating system for the resources. Now the next approach or next method for deadlock prevention, which is violating hold and wait, is called wait timeout. We place a maximum time up for which process can wait, after which process must release all the holding resources. Let's say process is holding the resources R1 and now it is requesting for R2, and it will request for R2 and wait till it will not get that particular resource. Now that waiting time should be limited. That waiting time should be limited. Let's say it is waiting for 5 seconds, 6 seconds, not more than that. So if we define that the waiting time for a process to acquire a resource, if we define, then this is called wait timeout. So what will happen? Here we are requesting for R2, I am holding R1. I have executed the process up to the requirement of R1. Now I have requested a fresh request R2. For R2, I'll wait for some period of time. If the period left, or if the period exhausted or lapsed, so what I'll do is I'll release, I'm not going to wait for R2, as well as I am going to release R1, right? So this is how wait timeout work. Next is called a deadlock prevention method for no preemption. How to violate no preemption. This is the condition, necessary condition for the deadlock. So the method is called forceful preemption. What will happen is we allow the process to forcefully preempt the resource holding by other processes. So here, because it is a no preemption, to violate, we have to preempt. So this method may be used by high priority process or system process. The process which are in waiting state must selected as a victim instead of process in the running state. So the idea behind the force preemption is, if a process is there and if it is having the resource R1 and it is holding it, and right now it is requesting for R2, and after requesting it will wait. So now P is in the waiting state. So what will happen is P could be preempted or forcefully deallocate the resource if some higher priority process is there. If let's say there is a P1 which is a higher priority process, or P1 is a system process, so P has to leave that particular resource which is required by, which is requested by P1. So P has to preempt, or P has to leave that particular resource. That is the idea behind forceful preemption. Now the next is violating the circular wait. How we can violate the circular wait? So circular wait can be eliminated by first giving the natural number of every resource. So let's say we have resource R. We have different resources, right? So we'll give the number to that. Let's say we have one resource, I'll give the number 1 to it. Another resource, I'll give the number 2 to it. Another resource, I'll give number 3 to it. So first I have to give the natural number to each and every resources. After that, allow every process to either only in the increment or decrement order of the resource. Let's say we have a process P1, we have a process P2, and we have a process P3. Let's say P1 require the resource. So we'll allocate, let's say P1 require a resource R2, P2 required a resource R1, and P3 required a resource R3. Which particular process I should give the resource first? So the first I'll give to P2, then I'll give to P1, and the third I'll give to P3. Why? Because I'll give either in the incremental order of the resource number, or I'll give decrement order of the resource number. Let's say I am using the increment one. So I'll give R1 first, and then R2, and then R3, right? Now the next is, if a process require a lesser number, means let's say P1. P1 is getting R2, right? Is getting R2 because it required R2. Now it is requesting for R1. If this is the scenario, then what I'll do is, in case of incremental order, then it must first release all the resource longer than the required number. So what is the required number is 1. So it has to release the resource which is higher than that. So this resource has to be released. That is the idea behind the deadlock prevention, which is violating the circular wait. So first, resource need to be given some natural number. Second, whatever allocation will give to the resources to the processes should be in order, either in an increment or decrement order. If we are using increment order, so we have to think of, let's say if a process is requiring the lesser number of resource, then we have to see what resource it is holding. If the holding resource is the higher number, so we have to release that particular resource. Now here what will happen is, let's say there is P2, right? P2. It is having R1. Now it required R2. Do R1 has to release? No. With this particular algorithm, what it is saying, or in this particular method, P2 is requesting R2, which is a higher number, not a lesser number than this. Then R2 will be granted to P2, and R2 doesn't have to remove or doesn't have to release. Okay. But here in this case, it has to release. So this is the idea behind deadlock prevention with circular wait. Right? So what I told you regarding the deadlock prevention, I told you like deadlock prevention could be done if we violate one of the 4 necessary conditions of deadlock. What is that? So here we have seen there are 3 methods which can be used for the, sorry, there are 3 methods for hold and wait. There are 1 method for no preemption, and there is 1 method for circular wait. So one method is there, and here we have 3 methods which can violate. So in the system we have to choose any of the method from these 5 methods. So we have total 5 methods, right? So we can choose any of the method and we apply here in the system so that it will violate any of the conditions, so that there will be no deadlock into the system. Why? Because these 4 are the necessary condition for the deadlock. If all these condition holds for a process at a particular time, then there is a deadlock. If any of the condition doesn't hold, there is no deadlock, right? So this is deadlock prevention techniques. I hope you understand it.